Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on machine learning fundamentals or the machine learning foundations. Now the number of projects, number of research is going on this machine learning and the different algorithms. So we must know the foundation or the basic of all the things, and gradually we go for the intermediate and advanced courses. If you see this machine learning, the deep learning, these all goes back to the artificial intelligence. So in this artificial intelligence, the machine that simulate human thinking capabilities and behaviors, that is the only simulation of human thinking capabilities and behavior that is done, attempted, that we call it the artificial intelligence. Okay, this is one sort of intelligence, artificial intelligence. And this AI, it basically makes it possible for computers to learn from experiences and perform human-like tasks. That is the thing we expect from this artificial intelligence. For example, say language translation, self-driving cars, speech recognitions. So these are the some of the things we can do using this artificial intelligence. Then how AI or artificial intelligence do these things? So they use artificial intelligence, use machine learning and deep learning algorithms. Then the important thing is that what is this machine learning, what is this deep learning, all the things we learn. This machine learning, it is an application of the artificial intelligence that provides the system ability to learn automatically. That means some data will be given, from that it will learn and it will be able to predict. Okay, so this without being explicitly programmed, it will learn automatically. That is the concept of machine learning. Then what is deep learning? So this deep learning, it is developed as a machine learning approach to deal with complex input output mapping. So entirely it is a input output mapping, that is the deep learning. Okay, you are using the neural network or the artificial neural network, the concept will be using there. Then diagrammatically or pictorially we will explain like this. If you see the artificial intelligence, so this is the you can see the universal set, and this is the theory and development of computer systems that is able to perform tasks normally requiring human intelligence. Okay, what the human is doing till now, that the machine or the computer has to do. Then subset of that is the machine learning. What you is just narrowing down the thing. The machine learning, it gives computer the ability to learn without being explicitly programmed. That means from this existing data or existing, it will learn and it can use some data for prediction, right? Then if you see the deep learning, this is also machine learning algorithm with brain-like logical structures of algorithms called the artificial neural networks. So this we have some idea about what are the things. Then the question comes, why this AI based machine learning has become so much popular in recent years? It is because of the increase in data. We have a huge data. Okay, so this data, using this data we can get insight for any business or anything, for any type of things, any domain. Then what is this data? This collection of observations we have about something, this we call as data. And why this data matters? So it helps us understanding the things as they are. Then how does it help? The question will be like this. It help organizations or individuals for better analysis and predicts the outcomes. That is the reason we are going for these things. See, if you see the history of this data and how this data is related to machine learning, in the last 10 to 15 years, data has been increased enormously. It is just exponential, it is increased. I will show you statistics so you can clearly understand. So till 2005, 130 exabytes of data has been created by humans. I am talking about 2005, which is around 20 years back. And by 2010, after 5 years, around 2000 exabytes of data is created. And by 2000, I am giving the data every 5 years. By 2015, so it is 15,500 exabytes of data. You see how it is increasing, exponentially it is increasing. By 2020, it is around 65,000 exabytes of data, and by this time it is some petabyte of data it is already created or generated. With increase in volume over the years, machine learning algorithm has been developed to handle huge volume of data. That is the main thing we are going for this, or relating the data to the machine learning. and the normal statisticians could not be able to extract the patterns from data because of increased volume in data. So if the data is limited, some 100 lines or like that, or limited number of columns, one can do, but when huge amount of data is there, number of rows or number of columns, it will be difficult by the statistician to predict. So see this graph here, you can understand from 2010 to estimated by 2025. You see this is the data volume in zettabyte, you can see here, and it is expected by 2024 here. If you see it here, it is already 147 zettabytes of data is there, and by 2025 it will be 181 zettabyte of data, you understand. So this is the estimate of data for the next few years. Then what is this application of this machine learning, where you want to apply? See, the Facebook facial recognitions, whenever we open any photos, names will comes automatically because Facebook has already recognized that face in some time. Okay, so this is one of the application. Similarly, in artificial intelligence gaming, games like chess, tic-tac-toe, etc., these are things also they are using this machine learning. Then voice recognition, if you see in iPhone, instead of texting, there is an option to speak in which word will come, which is voice recognitions, right? Then the language translations in Google are also, you are also using these things. Then the robot dogs, nowadays so many YouTubes are coming, they have the dog fighting with the real dog, or robot tiger is fighting with the tiger or chasing. This machine learning teaches the dogs how to move, which can be done by recommendation systems. Then the medicines, many lives can be survived using data sciences in medical fields. Then YouTube recommendations like Amazon ad or Netflix, Facebook ads, all things it is there also can be done using the machine learning. Finally, the driverless cars, etc., many more we will discuss in this course. So you see in some advanced countries like USA, you can see in Singapore, even other parts of the Europe also. So driverless cars are there. Just you give the starting point and the destinations, and if the financial part is over, it can take you to the destination safely. Then let us explore what are the different types of machine learning. So broadly we divide into 3 categories, but here we have gone for the 4 category, that is the supervised learning, unsupervised learning, semi-supervised learning, which usually you don't use, then the reinforced learning. Last two only we will be discussing, but mainly we will be using the supervised learning, and sometimes also we will be going for this unsupervised learning. And this supervised learning, if you see here the left hand side here, that this part, this divided into 2. One is the continuous target variables, another is the categorical target variables. Continuous target is some numerical values will be there, when x is equal to 1, y is equal to something, 1 square is equal to 1, when x is equal to 2, y is equal to x square is equal to 4, like that. This is the continuous target variables we are taking. But here in the other part is the categorical target variables. So this continuous target variables, we are calling it the regression. The categorical, so it is going to a class and all things, and that they are calling. Say suppose I am classifying some fruits, one is apple class, one is the orange class, one. So this is called classification. Okay, for example, regression, house pricing prediction, etc., this is coming under the regression. Classifications, medical imaging, etc., this is coming under the classification. So these are the things coming under the supervised learning. Then coming to unsupervised learning, mainly the target variables not available. It's clear, there the target variable is not available. So then we go for some clustering or association. Clustering means some customer segmentations, and association means market basket analysis, like that. These are things it is coming as association. Then coming, these are the examples. Okay, then the semi supervised, we are going for the categorical target variable, and here you can go for the classification, we can go for the clustering. Classification example, the test classification, and clustering, the lane finding in GPS data. Okay, so these are the some of the types. And then you go for the reinforced learning. Here we can have the categorical target variables and the target variables not available. These two cases are possible. When categorical target variable are available, then did the classification. When target variables not available, did the control. So the example for the classification is the say optimized marketing. Okay, when coming the control, the steering control, etc., it is the driverless car. Okay, so driverless car and all things, it is coming under the reinforcement learning, right? So these are the some things. And if you analyze all the things. The supervised learning, we know the input and output beforehand. In unsupervised learning, we know only the input but not output. So we want to classify to some class like, and the model learns from pattern and produces the desired output. This is the unsupervised learning. Semi-supervised learning, what it happens, falls in between the above types. Some observations in data has labels and some does not have the labels. So in that case, we can go for this semi-supervised. Are you following? The label data means it is mango, so it will come out. So then the reinforcement learning, the training of machine learning models to make a sequence of decisions work on basis of if-then condition. These are the reinforcement learning. So now there is clarity. Then let us switch over to this machine learning. The machine learning, there are two main pillars. One is the data, and then is the machine learning model. So if data is available, we select a model, then we try to train the model. Once it is trained, then we go for the testing by applying something. We go for that one, right? So when we feed this data to model, it will learn from the data. That means it finds the patterns from this data, so that whenever we give a new data, it will predict the new values. This is the concept of all things in your machine learning. For example, if you want to build a model which predicts the blood sugar level of a person's, okay, diabetes, something like that, blood sugar, then we need to select appropriate model and train the model with lots of diabetes data, right? And whenever we give a new data, it will predict the sugar level based on some medical parameters. This is how every machine learning models works, right? So this is the example we got it that. Then before we starting the machine learning algorithm, we need to understand a few terms like what is the mean, what is median, what is mode, what is variance, what is standard deviations, what is the correlations, multicollinearity. So these are the things, it's an important terminology we'll be using there. The mean we clearly understand, the average of data points. Suppose data point first one is 3, second one is 4, next one is 5. So 3 plus 4 by 5 divided by 3, it is 4. You get it now? This is the mean. Then coming to the median, this is the middle value in the set of odd numbers of values. If it is odd number, suppose 3, 4, 5, so 4 is the middle value. If it is 3, 4, 5, 6, take the average of 4 and 5, convert to the next one. So that this in this way, if the middle value of this set is odd, then it is the middle value. If odd number of values are there, if the number of values are even, then take the average of the middle two numbers, right? So this is the median, we take it. Then coming to the mode, the most frequent occurring values we call that the mode. Then what is variance? How far a data point is from the mean value. So we take the mean value and your data point, how is the difference, how far it is from that one. This is called variance. Then what is the standard deviation? It gives us the information about how your data is spread. This is the standard deviation. We have some formulas here. We can see it here. In case of population, in case of sample, how do we calculate the variances, or how do we calculate the standard deviation? So variance is represented as a sigma square, which is equal to summation of I is equal to 1 to n xi minus mu whole square divided by n. N is the number of sample here. Okay, so this is the things you can get it there. Then are you getting me? So then when we are giving the standard deviation, it is the square root of that one. Similarly, in case of sample, so a square, which is equal to summation xi minus x bar, that is the estimate of that one, square. So I is equal to 1 to n divided by n minus 1. Okay, this is the thing, and s is equal to square root of that one. So this is the formula we are using for variance and standard deviations, right? Then we come across something regarding what is this linear regression. Once we have some idea about the regression, then we will move to practical session, how we use this Python for all these things, because we have to deal with a number of libraries, Python libraries and packages. So once we know all the things, so then while we are going for this part 2 of this video, then we'll go for actually dealing with the machine learning algorithms, right? Now let us see. So this regression or the linear regression, it is a parametric techniques used to predict the continuous variable given set of independent variables. Okay, so independent variable is given, we plot it in the x-axis, in the y-axis the dependent variables, you plot a graph, whatever things are there. So there we train the model and we try to predict some new values. When new x is given, what is the corresponding y value, we find it out. Okay, so it shows a linear relationship between the dependent variable and the independent variable. So independent variable, they are represented in the x-axis and the dependent variable are represented in the y-axis. So we can put it y is equal to b0 plus b1x plus some error terms are there. Are you getting me? So what is this? It is just like y is equal to mx plus c. So if you see, m is the slope, here that is the same value is b1. C the intercept on the y-axis, here it is written as b0. Same thing, y is equal to mx plus c, that is equal to y is equal to b1x plus b0 or b0 plus b1x. Then some error terms are there because by default it is not mapped to a model. It is not in a straight line. Data will be here and there, above the line, below the line. So that is the error term. So error term is nothing but actual value minus predicted value. Actual came some 8 but predicted is 5, so this 8 minus 5, 3 is the error, right? And we cannot completely eliminate the error, but we can reduce the error. So to reduce the error, regression uses a technique we call it the ordinary least square or OLS. Now onwards, the ordinary least square will be calling it the OLS. Clear? Now what is this OLS? This OLS tries to reduce the sum of the squared errors. What is the meaning of that one? Say one is the actual output and one is the predicted output. Okay, so square of actual square of what is this? Actual y minus predicted y and their sum we call it as the OLS. And finding the best possible values of the regression coefficients, then we can calculate all the things. And it finds the best possible values of the regression coefficients by using the gradient descent algorithm. And the main objective of regression is to find the best value for b0 and b1. Once you find this b0, b1, then we can find the straight line over you are representing the model. Then putting other values of x, we can also predict the y. Now the different regression techniques differs based on the number of independent variables. If we have a single independent variable, then it is called a simple linear regression. If we have more than one independent variable in the x-axis, it means a multilinear regression. Are you following me? What I am telling, that in the x-axis, for a single value of x-axis, there is a single value of y, your dependent variable. So this is called a simple linear. For example, suppose I want to calculate something like that. What is the price of a something like that, when x is equal to something, how to predict y. So this is linear. Suppose I want to predict the house rent of a house based on so many parameters like the location, the number of bedrooms and the bathrooms attached, then any nearby hospitals are there and any universities is there. So based on so many things, the price will be decided. So what is the price in a metro city? It may not be the price in a rural area. You get it now? So these are, that means the input x-axis, the independent variables are more, and y-axis anyway obviously it will be 1. So these are the cases of multilinear regression, right? So then take an example here. So suppose the experiences in year. So when somebody joins, he is getting 2 lakhs. After 2 years, he is getting 4 lakhs. After 4 years, he is getting 8 lakhs. 6 years, 10 lakhs. Something like that, like it is coming. So what if we want to know the salary of 3 years experience? Because 0 is given, 2 is given, 4 is given. So if you plot a graph, then when the x is equal to 3, when the y-axis meets the line, then we can easily calculate all things. If you build a regression model on the above data set, the regression will look like this. You see the next one. See, so I am plotting it there. Say actually when I am plotting, see, when I am plotting, the data points coming here, 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 like that, you see. So this is not exactly a straight line. So what I do, I fit it to a model. That means, so it will be this point will be close or equal distance. On what basis we train it and we make it a linear model like that. That means instead of these points like this, so this is represented by the straight line. Now when 2, this value is valid. When 4, this value is valid. But when it is 3, maybe this value is valid. Okay, so it will be around if you see it here, it will be around 55,000 or something like that. The value will be there, or 50,000, 55,000, it will be there, like. So this is the way how we can predict. Okay, so if you see here, the actual value or true value are represented by the blue dots, but the prediction will be by this straight line, black line. Clear? So this is the how a linear regression model works. Then how to find the best fit line. That the line what you see there, that the black line, so we call it the best fit line because so many lines can be drawn with those points. What is the best fit line? Then we see how to find the best fit line. The regression line, the line which shows a relation between dependent variable and independent variable, we call it the regression line. Then there are two types of regression lines. One is the positive regression line and second one the negative regression line. Positive line, if the dependent variables increases, when independent variable increases, then such relationship is called the positive regression line. Are you following me? If dependent variable increases, when the independent variable increases, that means it is going upward. Are you following me? So when x is increasing, y is increasing, this is called positive line. What is the negative line? If the dependent variable decreases when independent variable increases, this is called negative regression lines. That means it is going down. You get it now? What is the best fit line? The line with least error between. So see, it is not that the positive line is a best fit. No, it is positive negative, that is material. But the line with least error between the predicted value and the actual value, if the error is least, then we call it as the best fit line. It's clear? So in regression, we can minimize the prediction errors by finding the best fit line, and the distance between the regression line and the actual point should be minimum. That is the thing you try to understand. It's clear? So you take it here, say for example the same thing we plotted it here. So between I think for x is equal to, I think the value it is missing some part. Okay, but modify this thing. Yeah. Now if you see here, still it is not showing. Okay, escape. Okay. Yeah, now you can understand. So now suppose it is given when x is equal to 1, y is equal to 5, when x is equal to 2, y is equal to 7, x is equal to 3, y is equal to 9, x is equal to 4, y is equal to 11. It is given there. So we plot it now. How do we plot it? So all the things we plotted there. So once you plotted all the things, from this we can predict when x is equal to 3 or when x is equal to 2.5, whatever things we can predict. Even the before 1 also predict, after 6 also we can predict, right? So this is how we do it here. Now the different values of b0 and b1 gives different lines. You understand, because y is equal to mx plus c. When c is different and m is different, line will be different, because when slope is different, line will be different. Here the different values of b, these are the coefficients. Okay, so when b0 and b1 are different, it gives different lines. Okay, and we need to calculate best values of b0 b1. How to calculate? Because we want the error should be minimum. To find the best value of b0 and b1, we use some cost function. So what is this cost function? This is used to find the accuracy of mapping functions. Mapping function is nothing but the function that maps input to output. Okay, this is called the mapping function. And the different lines will have different slopes. Put the b0 b1 values in the regression equations. With the resulted equations, we can get the y values for the given x. That is the prediction. For linear regressions, we use the mean square error. Remember, for linear regression we are using the mean square error as the cost functions, right? Now there is something called the residuals. The distance between actual value and the predicted value, this is called the residual. The distance between the actual value and the predicted value. So it is just like the, if you from that point, if you draw a perpendicular to this line, actual value is something above that one and the line is below that one, and draw a perpendicular to that one. So this is called the residuals. If the observed points or the actual points are far from the regression line, then the residual will be very high, and so cost function will be high. If the actual points are close to the regression line, then the residual will be small and the cost function is also small. So this is the things you understand, what is the residual and what is important. Then what is gradient descent? It is used to minimize the mean square error by calculating the gradient of this cost function. Okay, so by calculating the gradient of this cost function, we can minimize the mean square error. And the regression model uses gradient descent to update the coefficients of the line by reducing the cost functions. It is done by random selection of values of coefficients and then iteratively update the values to reach the minimum cost functions. Okay, initially we take random values, then with the iterations, then we go for the correction, right? So this is the things we will go for model when then we go for the multiple linear regressions. I told you what is this multiple linear regression. And the x-axis or independent variable, so many values are there. So in that case we call it as the multiple linear regressions. You can see it here, and it cannot be represented a line, it will be represented just like a plane. You can clearly see it here, right? Then what are the assumptions of linear regressions? These are the some of the assumptions. One is the linearity. It assumes that the relation between the data points is linear, that is plot of the data point should be linear, just like a line. Independence, the independent variable should not possess any relationships, so one does not depend on others. Normality, data points should follow normal distribution, that is if you draw a histogram, it should give the bell shaped curve. You can see the histogram of that one, the coefficient estimations and the density. This is, it will be distributed like this, so then we call it the normality. Then there should be no multi-collinearity between the independent variables, and multi-collinearity means having high correlations between one or more features, and due to this multi-collinearity it is difficult to find the which variable is affecting the target variables. That is just like the depending one is depending on the others. Then homoscedasticity, it means error term should be constant for all the dependent variables. Opposite to homoscedasticity, the heteroscedasticity, it is in which error term is not constant. The first case it is constant, second case is not constant, and all the independent variables should be uncorrelated with error term. And there should be no audio correlations between the error terms. There should be no autocorrelations between the error terms, and autocorrelations usually occurs if there is dependency between the residual errors by the DVs. Okay, dependent variables, and error terms should follow normal distributions. It can be checked using the QQ plot. If a plot shows a straight line without deviations, which means that the error is normally distributed. So these are the some of the things, and how to evaluate the LR model performance. So one of the things I told you that MSE, or the mean square error, average of the squared error between the predicted values, and the, you understand the difference between the actual and the predicted, this is called the error, and the average of the squared error, because sometimes what will happen, so error is -1, error is +1, the average will be 0. No, they go for that average of the square, because irrespective of the sign, if you make it square, the value will be there, because if you plus minus it will be 0, so that means there is no error, but actual error is there. Now the coefficient of determinations or R square. Okay, the coefficient of determinants we call it the R square value. How to calculate the R square value? It is a statistical method that determines the goodness of profit, and it measures strength of relationship between the DVs and the IVs, dependent variables and the independent variables. It measures the proportion of the variations in your dependent variables explained by all of your independent variables in the model. It assumes that every independent variable in the model helps to explain variance. So how to calculate? So your value ranges from 0 to 1, that means 0 to 100%. R square, which is equal to explained variations divided by the total variations. Okay, what is R square? R square is equal to explained variation divided by the total variations, and R square, there is a mathematical equation. So one is the SS REAC, that is the unexplained variations, and SS REG, that is the explained variations, SS total, that is the total variations, and then you find the adjusted square R square. R square is equal to 1 minus SS RES divided by SS total. Okay, equivalent to this one, which is equal to, if you calculate it, 1 minus summation of y minus y bar square. You can calculate all the things, and from this we clearly find that, so 1 is very small value, so in that case it will be SS REG divided by SS total. Okay, this is the R square value, right? So this is the then another is the root mean square error, RMSE, and the mean absolute error, MAE. So these are the things we use for calculating these things. So then let us go to our part, what actually we are going to do with these things. See, First of all, I am using this Anaconda 3, and as you know that by default this Jupyter notebook will be there. There is no need to install it separately. So you need some libraries. Say for example, I will be using NumPy, I will be using Pandas, I will be using so many things there. And now let us understand what is this NumPy, what is this Pandas, and what we are going to do. See, this NumPy, these are primarily used for creating arrays or matrices, and also the numerical operations on large quantities of data. When large quantities of data they are to be represented by arrays or matrices, in that case we need to use this NumPy or numerical Python, whatever things you say. And this NumPy makes n-dimensional homogeneous objects. Then how to install? So pip install NumPy. I have already given the command here. Just you control and enter, it will run this command. I already run it there just now. Then pip install Pandas. So this is, it will be installing Pandas. So what is Pandas? Pandas is used for data wrangling and also data manipulations. When you go for data manipulation and wrangling, then you need that Pandas. And another thing that Pandas is used for creating heterogeneous two-dimensional data objects. Okay. Now I need NumPy for the matrix and the arrays, and these Pandas for all these heterogeneous two-dimensional data objects. Okay. Heterogeneous, it can be a number, it can be a name, it can be any address, anything it can be there. Then how do we use? Before using, you have to import all the things. So import this NumPy and save it as np. So import NumPy as np, import Pandas as pd. Now onwards, instead of NumPy we will be using np, and instead of Pandas we will be using pd, right? Then we have two things in front of. One is the series, another is the data frame. What is the series? This is the single column or the index column. Index column means 0 is something, 1 is something, 0 indexed, like that, or x is equal to 2, y is equal to 5, 7, z, like that. This is the index. Then another the data frame. Here more than one column, this we call the data frame. Just like a table, we can see the data frame. Now I am taking an example. Suppose I put some values 10, 20, 30 and put it a variable my data. That means my data, if I find that one, so it is carrying the data 10, 20 and 30. So now I declare a array np. Then what I will be using? For array I told you that I will be using NumPy. So np dot array, which one? This my data, whatever the data already you declared, which I save it as array. Okay. Now if you call this array here and control enter there, the array will show 10, 20 and 30. If you want to see the type, data type, then it will show that it is a array, right? Then suppose I want to put some labels, like labels can you put labels is equal to under the square bracket under single quotations a comma b comma c. And suppose you want to declare a dictionary, so my dictionary, which is equal to, it is just the key value pair. So for a it is assigned 10, for b is equal to 20 and c is equal to 30. So a, b, c they are all in single quotations, and this value 10, 20, 30 they are separated by colon, and one key pair is separated by a comma. You can, and it is put in the curly braces. This is the dictionary we are using. When you call this my dictionary, just my dictionary, my underscore dict, enter, control enter, then it will give you a value is equal to 10, b value is equal to 20, c is equal to 30. It is there like this. Now suppose I was using the series. Suppose I want to use the Panda. So pd dot series my data. What is my data? My data already I given 10, 20, 30. So then what will 0 index, 0 is equal to 10, 1 is equal to 20, 2 is equal to 30, and the data type is equal to integer 64 bit, right? Now suppose I want to create something pd dot series, then data is equal to my data and index is equal to xyz. That means here it was taking 0 index 0, 1, 2, 3. No, here it will take x is equal to 10, y is equal to 20 and z is equal to 30. Same thing you and you save it as series 1. Then if you type that series 1 ser 1, then it is giving x is equal to 10, y is equal to 20 and z is equal to 30. It's clear? Then the series without index, if I wanted that one, what we want, then series without index is equal to pd dot series my data. You just give it here. So here giving same thing 10, 20, 30, but 0 index, first index, second index, it is giving here, but previously it is giving x value is this one and like that, because we put it in a different format. You just go through this one, pause this video, and you can clearly understand, and you can practice in your system also. Then series without index also you can put it here, the data my data and index, so it will come that it is there. Then if you call this series without index also it will come, series without index, the same thing it will come there, right? Then type of series without index, so it is coming just series. Then I am putting series 2 and pd dot series 2 my data comma labels. So what is the labels? Labels already somewhere we have put it, label is equal to a b c. If not given, then you can give it here. I think somewhere I put it label is equal to ABC. Yeah, label already given ABC. Okay, so then what you do, then you put it there. That means in the pd dot series is creating, and first is my data and labels. Label means ABC. A will be 10, B is equal to 20, C is equal to 20, C is equal to 30. So this is stored as ACR2 series 2. When I run this ACR2, then it will give the things like this, right? Then series using array, I save it with this variable name pd dot series data is equal to array and index is equal to labels. So ABC, same thing, it will, the different type of output will come. Then series using dictionary, see all the same thing it is, you can do it here, my dictionary if you want. So the values also, values it is showing. Then series using dictionary also, you want ABC and value is equal to 10, 20, 30, all these things you can see here. Now suppose I want to put some advance of using this list over this arrays. How to create a list? See, arrays is, I told you that the similar type of things will be there, but list, anything I can put it here. For example, I put a number 2, second one I put a DS training, data science training, third I put day 2, like that, and fourth I put a floating number 4.56.90. These are the different type. This is not homogeneous, right? So how do you access that one? So this I saved it as label underscore sample. So in the square bracket, all the things, if it is the number, it will be there the number. If it is some string, then it will be under the single quotation separated by comma. It's fine. Now I write for I in this labels underscore samples, print I. So now 2 is coming, DS training is coming, day 2 is coming, all the things are coming here. Similarly, for I in label sample, print type I. So this first one is automatically, this is has taken as an integer, second one is taken as a string, third one taken as a string, and the fourth one it has taken as a floating type. So automatically it has taken. That's the beauty of this thing. Okay, then which type of data can pandas series hold? And it can hold numerical data. Try to understand. So it can also so if you see print pd dot series dot array, then to it can also hold text data. So print pd dot series dot labels. So it can show it some numerical data it can take, and it can also take the text data. Then third, it can hold built-in functions pd dot series dot data some print length. So this is also possible, right? So for this, if you run this program, and you can also see all the things here. Then pd dot series dot data, suppose I create something, the data is equal to machine learning, natural language processing, deep learning, and CV, something like that. Okay. So then this will be 0 index, 0 is equal to machine learning, 1 is equal to NLP, DL, all the things it will come. So pd dot series, suppose I put it 1, 2, 3, 4, and I put it there, then what will say? Machine learning is 1, NLP is equal to, otherwise by default it is 0 index, it will set. This is also you can do it here. Then suppose I go for series 1 is equal to pd dot series 1, 2, 3, 4, all the things, and series 2 I put it 1, 2, 5, 4, these things I put it there. Then you can print series 1, print series 2, all the things you can get it here also. Similarly, indexing by name also you can do is the series 1 of 3. What is the third value? It is here. So 0, 1, 2, 3, third value it is coming 4. So you are seeing it 4. So getting the data values, all the things we can see it here, and print the series 1, 2, 3. Okay, 0 value it will not come. So 1, 2, 3 means it will come NLP, CV, and Python. Then you can see it is coming, right? So like that, you can go for even if you can go for merge two things. Okay, adding or merging. Series 3 is equal to series 1 plus series 2. Then if you call the series 2, then the 2 it will be merged here. And series 4 is equal to series 1 and series 2. So it is multiplied. You can get it here also, and you can see all things. You can find it here, right? So in this way, we can do the basic operations. So this is the very fundamental things I told about this thing. In our second part of this, this machine learning foundations, we'll be talking about some of the operations of the pandas, and how we take selected values, then we declare some of the data sets from the Kaggle and other things, and how we load this data and how we use this data. We'll be using that one. So our target is only 100 subscribe. If 100 subscribes is there, then definitely I am going for the second part. So I request you all to subscribe. Let's just share this video with others. Thank you for watching this video. Have a good day. Thank you.